Hello everybody and welcome. Today I'll be starting a new project tutorial. This is hopefully going to result in a game similar to a StarCraft or some sort of resource collecting game. We'll start out by using the Scratch Cat. We might change it out with a different art piece later. But in this first video we're going to nail down how to do a click to move similar to MOBA games like League of Legends or Dota, where you click a spot on the map or your screen and your character will find a path there. So we're going to lay down the framework for that, and then we'll come back later on and add a few things to make it more solid. So we're going to start off by making the variables needed. So in a sense, what we're going to do is all within this cat, we're going to make one script, and it's going to hold within variables the location of the mouse click. So we're going to, when we click, it'll store the X and the Y of the mouse in two variables, and then later down in the script, it'll start moving towards where those variables are set. So if we re-click halfway through the move, then it'll change its route. So we're going to make a repeating loop, and the quickest way to do that is to have a when flag is clicked forever. So this will repeat whatever is in this block continuously for the entire project. So now, oh yeah, the variables. So we're going to make two variables, and we're going to make this for this sprite only. The first one's going to be called, we can call it mouse move X, and make another one for this sprite only, and call it mouse move Y. Okay, so you can see the values up here right now, they're defaulted to 0. But what we want to check for in every loop, every time the game cycles, is if we click down the mouse. Most times we won't be clicking, but occasionally when we want to click, we want it to see that. So we're going to constantly be checking to see if mouse is down underneath sensing. And when that happens, we want these variables to be set to wherever our mouse is at that time. So we'll set mouse X, and we'll set move mouse Y. And then underneath motion, you can find, oh no, sorry. Yeah, underneath sensing, because we want not the cat's location, but where the mouse is. So underneath sensing, find mouse X for the move mouse X, and then mouse Y for the other one. So if we hit the green flag, we can see as we click around, the values will change. And if we drag the mouse right now, it'll keep resetting to wherever the mouse is, because the mouse is continuously being down. So that's the first half of it. Now we need to have the cat move in that direction. And we're going to have 4 separate block chunks that we're all going to put underneath this for loop. But they're all going to look essentially the same. So basically we're going to check to see if the cat's position, say its X position, if it's greater than or less than the mouse move. And if it's greater than, we're going to move it back, and if it's less than, we're going to move it forward so it matches. So we're first going to check, so if the cat's X position, and then under operations, is less than sensing, or no, the data, mouse move X, then we're going to do something. So we're going to put these in here. So this reads, if the cat's X position is less than the move mouse X, then since it's less, we're going to have the X change by, say, 2 for now. So now we can test this out. If the cat's stationary right now because the values match, but if we click over here, it'll move forward until it gets to my mouse, and then I can still move my mouse around. If we click back here, nothing's going to happen because we haven't scripted the move back, which we're going to do right now. So we're going to actually take this, right click and duplicate it, and then change a few values. So we can right click here and and make this greater than. So if X position is greater than mouse move X, we can change the X by -2. So if it's further than the mouse says it should be, then continually move it back. So now we can do this back and forth like that. So now we just need to add the Y, and it's similar, but we still have to change a few things. So first of all, we're going to need to check for the Y position, and I'm going to go ahead and make this less than. So if the Y position is less than mouse move Y, then we are going to change Y by 2. Let's check if that worked. So you can see now it jumps up now. And it doesn't go down, obviously, because we still need to script that, so we can just duplicate that and flip the values. So if Y position is greater than mouse move Y, then change Y by -2. So everything should work. The only thing that looks a bit off is that it'll solve each differentiation at the same time. So you'll see it'll kind of flatline and then continue on the X till it's kind of going in like a, I don't know, like a zigzag type formation. We can change that later. We can maybe use a different method, but for right now that's fine. There's one more thing I want to add, and that is speed. So just to make it easier to change everything later, I'm going to make a variable called speed and insert it into every spot we use this number 2. And for the -2, so basically we want to be able to change this value, and it changes the speed for all directions. And so for these two, where I already put it, it's not going to be a problem because it's already a positive number and these numbers are the same, but these are opposite. So a quick fix for that is to take 0 minus speed, so that'll always do the inverse. It'll basically make speed what it is but negative, so that way it'll still go backwards and we won't have any problems with that. 0 minus speed. So now we can set speed at the top to something. Say we can start with 2 and just see if it works. Yeah, no problems there. And if we wanted to change something, we go up to 4. Yeah, now he moves a lot faster. And then this should even work for fraction, or not fractions, decimals, 2.5, so you can kind of narrow down your exact speed. So that's all I'm going to cover in this video. In the next video, we'll start adding some scene elements and things like that.